This thing is my new toy. This is what's apparently known as a Hing EK-001 toy keyboard. I stumbled across this on eBay on my usual jaunts of looking through eBay sections. It was listed in completely the wrong section without the right model number or name or anything. It pretty much just said toy keyboard. I recognised it immediately. I've been after one of these for a little while, and it was on a really cheap buy it now, so now it's mine. As you can probably tell, I've done a few circuit bends on this. This particular keyboard, mostly thanks to one or two particular websites, is notorious for being a perfect candidate for circuit bending. And having finally got hold of one and raiding my parts bins for a few things to use and try, I ended up spending a week doing a few mods on it and having loads of fun. I thought I'd do a little video on this and just talk about the mods that I've done, why I've done the particular ones I've done. And I'm not going to go into total detail about everything you could possibly do on this. Everything that I've used is information that's freely available online, and I will try and link a couple of bits in there. But I just want to talk through particular things that I've done to mine, and just a little overview of the instrument, because there's lots of demos of this, of people that have done circuit bends and such to it, but no one really talking about it too much. Just to go over a few basic features of the instrument. First of all, if you're familiar with the Yamaha PSS-30, which was a very popular kind of early mid-80s square wave toy keyboard, home keyboard, you might recognise this. This is more or less a bootleg of the PSS-30 in its button layout and more or less everything. I really love the look of this. It's almost sort of brutalist aesthetic. It's the sort of thing that suits extra bits and pieces added to it, really well. It's a basic 8-voice keyboard. It's biphonic, so it will only do 2 notes at a time. If you try and trigger a third, it won't trigger until you release and re-trigger. You have 8 voices on here: organ, violin, piano, horn, flute, guitar, music box and banjo. They all have slightly different envelopes and slightly different tones, but they're essentially mixes of square waves. In the rhythms, you've got 8 rhythm patterns with fantastic, really crunchy, almost Atari style drums. March, rumba, disco, pop, ballad, waltz, tango and swing. Tempo controls up and down, start, stop. And originally fitted to this there was a microphone input, which I've removed because it was basically useless. And you have a 3-position gain for the microphone input, which now does nothing, and master volume. The output for the headphones on the back, which is connected to my Zoom recorder at the moment, is shared with the speaker. It's not even on a separate preamp or anything like that. So it's a really hot output. If I wind the volume right up, it actually overloads the analog front end on my Zoom recorder. So I have to use it right down until I build some sort of attenuator cable to use it. I'll go over a couple of the features that I've added to this. Oh, I'm forgetting, just putting the box down, I'm forgetting the custom drummer buttons. These just trigger the individual drums, which is supposed to be bass drum, snare, a hi-hat I guess, and that which I think is supposed to be some sort of tom or I don't really know. It's pretty cool. So some of the features I've added to this, let's start in the top. This is a CPU clock speed control. If it's set right up or near to right up, it's more or less where it will come as stock, but if we turn it down, it will drop the clock speed right down. That also affects the drums, so you can get some really crunchy drum sounds, and it affects the vibrato speed and the rhythm speed. So the entire CPU clock is controlled from that, so you can get some really crazy kind of Game Boy sounds out of that. The next one along is essentially a keyboard attenuator. I've noticed that if this isn't fitted, if you plug it into a guitar pedal, for example, and try to run drums and keys at the same time, the keyboard will overload. If I crank it right up, it just overloads the drums. So this is in effect an attenuator, separate from the keyboard. In effect an analog volume control for the keyboard. This one is where the microphone socket used to be. This is now in effect a sustain switch. It uses an analog envelope in this. I will get to the circuit when I flip it over in a second. So this effectively grounds the envelope, so whatever the last key you pressed was will lock. So you can then use the controls as much as you want without having to hold the keyboard down, and the drums will still work. If you flip it back, or if you change voice actually, it will instantly change voice, and then if you flip it back, it will go back to the natural envelope. The controls on the bottom, probably the most interesting thing. It's switched off at the moment, but I've got an extra LFO added to this. If the switch is in the centre, it's off. And if I switch it left, it operates a slow LFO, and you'll see the LED start to blink, and you can hear that. And if I turn the clock speed down a little bit, it actually has more effect. So that's a slow speed, and there's also a fast speed. So you can get some really almost Commodore-like, almost like an arpeggiator. And then again, you can lock on if you want. And do some really crazy things with the other controls. The control on the right is a balance control between the internal vibrato, if I turn that on, and the LFO, the extra LFO. So if I turn them both on, we can get some really odd, almost sequencer-like things going on. If I turn it to the right, the vibrato will get deeper, and if you notice it cuts off there, depending on how some of the controls are set. This is so janky. I mean, half of this was held together with sellotape from the factory, and sometimes it just goes beyond what it can do, and the CPU will basically bottom out, it will stop. So you just have to notch it back a little bit, or adjust the clock speed a little bit. So let's go for a different sound. So we can get some really odd things going on with this, almost sequencer-like. And it will just, hands-free, just play itself. Again, we've got that control there, we can just push it into distortion. So we can do some really odd stuff with that. And that's pretty much it for the controls that I've added. I'll now go over the internals of it very briefly, and just what I've done and how I've tidied it up a little bit. So I'll disconnect all of this, flip it over, and then we'll take a look. Okay, so there are 10 screws around the edges that hold this together. Which of course I've removed at the moment, just for getting it apart quickly. And for some reason really common to Chinese toys, a screw in the battery compartment. You don't have to remove the batteries to get the back off. In fact, it's actually easier to leave them in while you're working on measuring or doing mods to the circuit. I believe there's a 9-volt version of this. This is a 6-volt version, takes 4 AA's, but one that's documented on the Table Hooters website seems to be a 9-volt version. From what I can gather, the 6-volt one is more common. But yeah, you don't have to remove that screw. So you have to be very careful when you remove the back, because the battery compartment was held on by 2 really thin wires. So you have to just set that aside carefully, you don't rip it off. Now, the first thing, if I try and centre that up in frame a little bit better, the first thing you might notice is there's a sea of yellow tie wraps holding all the wiring loom together. When this is in factory stock, the wiring loom's held together by good old sellotape, God bless Chinese labour. But you have to bear in mind, you know, that this is a toy, and it is really a bit of a bootleg. So it's kind of maximum jank, really. Even half of the component markings and stuff on the board, they aren't necessarily components in exactly the same holes. The values might not even match up, but it does work. Now, to go over a couple of points on this, hopefully that's not too overexposed and we'll be able to see what we're doing. In order to get 4 pots in the corners, I had to move this circuit board. This is the amplifier for the speaker output and the headphone amp, which are just coupled together. This was originally up at the top here, but because it's such a small board, some of the resistors, for example, are actually fitted on end, so they stick up quite a bit in height. So I wouldn't have been able to get clearance to get a pot under here, which would have been a shame, because not only does it look better when it's all symmetrical, but these corners are prime candidates for being able to get clearance for pots. And I can't put a switch at the top on this one because there's a post in the way that you screw the case screws through. In the one at the bottom it's slightly offset, so there's just room to get a single pole switch. So I managed to fit one here, but you wouldn't really have clearance, I don't think, for a pot to go there, and it would be difficult to actually get your fingers in to turn it. So when I was doing this, I was conscious of ergonomics in that sense of I want to be able to get to everything without it being too cramped, or without anything sticking out the sides or anything that's likely to get bust when it gets, you know, put into storage or put on a shelf or something. The best bit really was the double pole switch here for the sustain control. When I removed the microphone socket, which is here actually, just a standard little plastic mic socket, the double pole switch fits exactly, not only in the hole but also exactly in between the little plastic marks that hold the original socket in place, so that drops straight in, no problem. As I've said earlier, a lot of this was an exercise in using parts that I'd already got. Some of the wiring was new stock, some of it, like this grey wiring, was actually recycled from an old Ferguson VideoStar VHS video recorder that broke down and went to the tip a couple of years ago, so I ripped some of the wiring out and I've used that on a few projects since. And the pots were left over from a previous project, and I'd cut the shafts down on them a little bit, and they were just the perfect size for this. They're 470k linear pots, I believe. I then have a double pole linear 500k. No, it's a logarithmic because it's an A. 500k pot here. I'll go over in a minute why that's a double and what I've done with that. There are a couple of capacitors in line, just film capacitors. I think these are 100 picofarad capacitors in line with the output from the keyboard. The output is DC offset, so to avoid having scratchy noise on the pot and also affecting the pitch, I had to decouple that with a couple of caps there. The LFO switch here, which I'll get to in a second, just switches in 2 different value capacitors. Believe it or not, the smaller one's actually the higher value. I think that's if I remember right, that's a 10 UF, I think 25 volts, and that's a 1 UF. So to get the extra LFO, this tiny circuit board, it has been changed around a little bit. This little tiny circuit board is actually an old auto fire mechanism out of an old Commodore joystick, and I'd taken this apart when I was a kid, and I knew I'd still got this board somewhere. I think I got a broken joystick and ripped this little auto fire board out of it. I knew I'd still got this somewhere in a box, and I managed to put my hand straight on it, and it had got a couple of ratty old wires hanging off it, and I had no idea how to connect it up. So I started a few experiments with just a 9-volt battery and an LED to try and get the polarity and the output right and figure out how on earth it wired together. I believe in essence this is just a couple of transistor oscillators, relaxation oscillators as they seem to be known, that give roughly a kind of pulse width modulated sort of square wave output if you vary it with a pot. So I got loads of crocodile clips and stuff out. I'll include a few photos of the process of doing some of this. And this bench was just a mass of crocodile clips and scope wires and all sorts going on, just to try and find signals and put pots and components in and see what happened. I did have circuit diagrams, and I did have pinouts of the main CPU, which is on the bottom of this central board, but I can't really say I completely knew what I was doing. I was pretty much just clipping the scope into different things and seeing what I got. And if I got a wave out of something, for instance a CPU clock, then I knew I could go from there and do something with it. So the central CPU clock, for example, that's set by a fixed resistor, which I removed and just wired the clock resistor, the clock control pot there in its place. There is a resistor in line with it to give it a minimum because it kept bottoming out. So a lot of the pots have got inline resistors just to try and sweeten the range, the usable range of them. And depending on sometimes where you've got the different pots, sometimes it will bottom out and just stop. But it's just kind of par for the course with something so janky, really. It's just a bit of fun. So I managed to wire in this auto-fire circuit, and to get 2 speeds of LFO, it had a single capacitor in the middle, which is now switchable with either 2 capacitors or disconnected completely, which just gives it a solid DC output, which you can use as a kind of fine-tuning control. And I think I changed one of the resistor values here just to get a comfortable range. Now it needs quite a high resistor to be able to get a wide enough sweep. So what I ended up doing was using a 500k in series, so that it would give me a 0 to 1 meg sweep. If I'd have done if I'd have had a double 1 meg pot, I could have got even more. But I had that on hand, so that's what I used. The sustain switch, that simply grounds out the output, the envelope output, so that it pulls the envelope solid on. When you disconnect it, it connects back to the capacitors and then discharges its natural envelope. The vibrato control here, this is one of the most difficult to fit. I really should have heat shrunk the resistor that's just poked in there. This pot I think was originally here, and it's a bit janky because I ended up moving it. It's no more janky than any of the rest of this thing, but that goes into a fixed resistor, replaces a fixed resistor that was for the vibrato control. So originally this was just a vibrato depth control, it wasn't a balance control, until I involved this and then figured I could wire one LFO output, this one to one side of the pot and the vibrato to the other side of the pot, so it kind of acts as a balance control between the two. So this actually connects into the vibrato circuit, and it mixes, this pot basically mixes the 2 waves, which is why if you slow it down enough you can get that almost sequencer like performance out of it. And if you set the clock rate or the pitch low enough, the bottom of the LFO will go beyond what it can do, and then you'll just get silence. So it almost turns into like a tremolo control, which actually chops the output, so that can sound pretty cool as well. This little board was just held in with a little bit of hot glue against the plastic. There's a couple of other things I did consider. There is quite a lot of extra space here, which I did consider adding a couple of mods to. On certain versions of this I believe there's supposed to be a Zener diode. It may be in there somewhere buried, which locks the 6-volt battery output down to 5 volts. when the batteries go slightly flat, you get pretty much 5 volts out of it anyway. So I considered adding something like maybe a second order filter, a low pass filter, which if you were to run a couple of transistors in, you could probably make it active. To be honest, I've sort of run out of space to put pots comfortably. There's a possibility of putting one here, but it will be so close to this switch that you'd be banging your fingers on this if it was down, and I don't really want to compromise the ergonomics of it in that sense, really. So I think I'm going to leave that blank for now. If I ever find another one of these, I'll probably try a couple of different mods on it. Other things you could do, we could connect maybe a diode or a capacitor in line with the LFO, bring that out to a socket and have an external input for an LFO. If you've got a couple of these, you could have one output, one input, and connect them together, or even a clock output, so that you can sync a couple together, or, well, I say sync in quotation marks, because I'm not sure, you know, how much they would sort of lock up that well, you know, but I think that would be all part of the charm of it, really, to have a couple of these roughly working together. I didn't really go for any of the kind of glitch mods or anything like that. It's just not really what I'm interested in. In my opinion, a lot of these sort of glitch mods that people do to a lot of circuit bent instruments just start to sound the same, and I don't think they really exploit the individual instruments that well. What I wanted to add was more in a sense of performance controls, volume controls, and just interesting things like LFO steppers and just things like the attenuated air, just to make it more useful. If I want to make it glitch, I'll just put some flat batteries in it or throw it down the stairs, you know. I'm not really personally that bothered about stuff like that. I'm more interested in being able to use this through things like guitar pedals, in which case you need gain controls, or use it in the studio. So I'm hopeful that this is going to get used on a couple of forthcoming projects, maybe on soundtrack work or just general music. But I hope that's been a helpful little insight. As I say, I didn't want to go over the whole circuit or anything like that, just over a couple of the mods that I've done. I'll include some pictures, and I'll include some links to circuit diagrams and such, if anyone else needs any info on these. But yeah, that's my little Hing EK-001 with its new circuit bends. I hope this has been enjoyable. Cheers.